Okay, everybody, we're discussing today polynomial functions as an introduction, okay? So polynomial functions are functions of the form f of x equals a to the n, a sub n x to the n plus a sub n minus 1 x raised to the n minus 1 and so on and so forth until we go to a sub 1 x plus a sub 0. So all of these a sub n's are all real numbers and a sub n should not be equal to 0, okay? So also it is important that the powers are in descending order. Okay, so in this case my a sub n is what you call the leading coefficient, the highest power, which is n, that's going to be your degree, and the last term, which is a sub 0, that's going to be your constant term. Okay, again, if the powers are in decreasing order as we go from term to term, that's what we call a standard polynomial function in standard form. Okay, so these are basic types. We have the constant, linear, quadratic, which we have been discussing. Then we have now cubic and quartic. And these are the examples, okay? So let's have an example. Decide whether each function is a polynomial function. If so, write in standard form and state its degree, type, and leading coefficient, okay? So we have f of x equals, okay, 2x to the third power, okay, plus 5x plus 8, which is an example of a polynomial function, which is already in standard form because the powers are decreasing. Okay, the highest power is 3, which means the coefficient is -2. That's the number next to the highest power. Okay, let's have another one. Okay, so we have now here g of x equals -0.8x to the third plus square root of 2x to the fourth minus 12. Notice that this is also a polynomial function. However, the powers are not in decreasing order, so I have to move some terms. Then the one in standard form, it's going to be like this. Notice that the highest power is 4, and the number next to the highest power is square root of 2. That's going to be your leading coefficient. Okay? So when we evaluate polynomial functions, okay, so we evaluate them such as substituting the value for x, okay? So I'm sorry, but this is, we have f of x is 2x to the fourth minus 8x squared. It should be 8x squared plus 5x minus 7, okay? So all I got to do is just simply substitute that. And then we get now the values and simplify. We have f of 3 equals 98, okay? So another concept is what you call y-intercept, which is the value of y when x is 0, okay? So we're going to use that, which means if this is 0 in the example, 0 and this 0, because we're substituting 0, then what's left is going to be -7, which means f of 0 equals -7, which means -7 is our y-intercept, okay? Now, we're going to use some of those and some of these in learning how to write polynomials from graphs. So the first concept that we need to know is the concept of roots, or otherwise known as x-intercepts. So if in the graph, x-intercept is when the graph crosses the x-axis. Okay, so say for example, the graph crosses at x equals to 3, which means x minus 3 is a factor. Okay. Now, next one is a turning point. So it's a point in the graph where the graph changes from increasing to decreasing or decreasing to increasing, okay? So a polynomial of n degree will have n minus 1 turning points, and a turning point will have a square factor if it's an x-intercept as well. You can understand this later when we go to a specific example. Okay, and the last one is the x-intercept we was just described earlier on, okay? So let's have an example below. So this is the graph. We'll determine what the equation of the graph is, okay? What do you notice from the following? Now we notice that this one, the graph intersects at 2 points in the x-axis, one at 2 and -2 and one at 1, okay? So since it's an x-intercept at x equals 1, therefore x minus 1 is a factor. However, it also intersects at 2, okay? And it's also a turning point, okay? So in this case, it's an x-intercept and a turning point, which means x plus 2 is a square factor. So x plus 2 squared. So if I combine these two, my full function now would be a times x minus 1 times x plus 2 squared. All we got to do is find a. But y-intercept is 4, which means when x is 4 or 0, y is 4. So f of x is 4, x is 0. So if I substitute that, I get a equals -1, which means my full function now is actually equal to -1 x minus 1 times x plus 2 quantity squared. Okay? This is the factored form. Let's have another example. Okay? Notice in this example, we have three turning points. 1, 2, and 3, which means the power here would be x to the 4th. Okay? And then we have the graph intersecting the x-axis at these 2 points, which is at 1 and at 5. Okay? So, and at the same time, a turning point and an x-intercept, which means it's a squared factor. So, at x equals 1, which implies that x minus 1 squared is a factor. And at x equals 5, which means x minus 5 squared is a factor. So all I got to do, full function would now be the whole of this times 8. But it intersects at 30, right? So in this case, when x is 0, y is 30. So if I simplify that, I get a equals 30 over 25, or 6 over 5, which means my full function now is 6 over 5, x minus 1 squared times x minus 5 squared. Okay? Sometimes polynomials are being described by not using the graph, but it's just a description or a table. Okay? So we have now here the function f of x is a quartic function, which means it's x to the 4th, something. And the zeros are f of x are -6, -5, -2, and +1. We're going to assume that the leading coefficient of f of x is 1. So write the equation of the quartic polynomial in standard form. So standard form, which means it's going to be the long version. Okay? So since -6, -5, -2, and 1 are the zeros, which means x minus 6 is a factor. Okay? X plus 5 is a factor, x plus 2 is a factor, and x minus 1 is a factor. And then we're going to be assuming that a is 1 because it says in the problem, which means my f of x is just simply the same thing as that. So all I got to do is just multiply all this 4. I'll start with the first 2. So using FOIL method, so I get x squared plus 11x plus 30, while this one would be x squared plus x minus 2. And then I'm going to multiply this 2. Okay, so the one I'm going to be using is the table method. So x squared plus 11x plus 30, and x squared plus x minus 2. And then these are the products for each row and column. Then I just have to arrange them in standard form, highest power. Highest power is x to the 4th. Okay, there you go, which is this one. And then for x cubed is 11x cubed, and x cubed, which is 12x cubed. For x squared, it's 30x squared, 11x squared, and -2x squared, which is 39x squared. And the next one is for x, which is 30x minus 22, which is 8, and then -60. So this is your answer in standard form. Okay? Now, in some examples, you have presented it as a table. Okay? But you can see that the x-intercepts are -2, -1, and 3. There you go. Which means x plus 2, x plus 1, and x minus 3 are factors. And then we need to find the leading coefficient. However, we can find that because y-intercept is what? 6. When x is 0, y is 6. There you go. Simplify, you get now a equals 1. So which means my full function, if we go back to the full function, it's going to be the same thing, right? Because a equals 1. So all I got to do is simply multiply this. So I get now x squared plus 3x plus 2 times x minus 3. And then just simply do the long method and get this as my final answer. Okay? Do you have any questions? Okay, thanks.